this video, we are going to take a look at the Test 2A review. Let's jump on in here. So number 1 asks us to find the equation for the function that is finally graphed after the following transformations are applied to the graph of y equals x squared in the order listed below. Okay, so I'm going to start my equation with a y. And if I want to shift this graph right to, I need to, and now this is where it's counterintuitive, right? We put a -2 or we subtract 2 inside the grouping symbol. Now we don't have grouping symbols, so we'll make our own. But if I write x minus 2 inside parentheses and I square that, that will shift this graph right to. Okay, so I've done that. And like I said, this is counterintuitive. Right, we subtract 2. Left, we'd add 2. They also want us to reflect about the x-axis. Notice I left a space here because I was kind of reading ahead. To reflect about the x-axis, we put a negative sign in front here. So we've done that. And then finally shift it down 4. That would be a -4 in the back. This one is intuitive. Minus we do, or down is subtraction, and up would be addition. So this here, this new equation would shift the graph of y equals x squared right to, reflected about the x-axis, and shifted down 4. Okay, we have another one. This one has a different starting function, or parent function, if you want to call it a parent function. So we have y equals the square root of x. This time we want to reflect about the y-axis. This is when we're going to negate the x inside the grouping symbol, which in this case is a square root symbol. So reflecting about the x-axis, notice we put it in front, y-axis is inside. To stretch vertically by a factor of 2, we put a 2 in front, that'll stretch it. So we've reflected it about the y-axis, we've stretched it by a factor of 2. If it had said compress, we would make this a fraction. If it had said compress vertically by a factor of 2, it would be 1/2. But stretching, we use a number greater than 1. And then up 5 would be a +5 in the back. Okay, so this here would be the graph of y equals square root x with these 3 transformations. Okay, for this next one, there are a couple of ways to graph this. The way I'm going to graph it is I'm going to use the parent function. So the parent function is y equals the square root, not the square root, the absolute value of x. We think of what would this equation be in its simplest form. So no shifting, stretching, reflecting, or anything. So y equals absolute value x would be the parent function. So this is known as our parent. So I am first going to graph the parent. And to graph the parent, I'm going to make myself a t-chart here. Now my t-chart is going to correspond to this equation, not h of x. I'm going to deal with that in just a second. So if I plug in 0 for x, I get 0 because the absolute value of 0 is 0. If I plug in 1, I get 1 because the absolute value of 1 is 1. If I plug in 2, I get 2. Now, let me plug in a couple negative numbers. If I plug in -1, the output is still 1 because we're taking the absolute value of -1, which would be +1. And -2 would give me 2. So let me go ahead and graph this parent. I've got 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. So my parent function it's a V-shaped graph. Okay, now that's not what they asked me to graph. They've asked me to graph this h of x up here. But h of x is just a shift of our parent function. So h of x is my parent shifted. This means left to. This is where, like I said, it's counterintuitive. Plus, we would normally think right, but it's actually left. So I'm going to go left 2, and out here is intuitive, minus is down 5. So I'm going to move every point of my parent function left 2 and down 5. So I go left 2, down 5. Left 2, down 5. Left 2, down 5. Left 2, down 5. So my graph is still V-shaped. It was just moved left 2 and down 5. Like I said, it's not the only way we could graph that, but that was the theme of this section, was using parent functions and transformations. Okay, we've got another one here where I'm going to use a parent function. So the parent function for this equation would just be y equals x squared, just the most basic form of a quadratic equation. So I'm going to do a t-chart again for the parent function, not for this. We'll shift in just a second. If I plug in 0 for x, I get 0 because 0 squared is 0. If I plug in 1, I get 1. If I plug in 2, I get 4 because 2 squared is 4. Let me plug in a couple negatives, negative 1, negative 2. If I plug in negative 1, I get 1 again, and negative 2 gives me 4 again because we're squaring. We square negative numbers, we get positive. So 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. This graph is a U-shaped graph, also known as a parabola. Okay, so here's my parent, but that's not what they asked me to graph. They asked me to graph this f of x, which is x minus 1 quantity squared. Because we're subtracting 1 inside the parentheses, this is either left or right. And like I said, it's counterintuitive. It actually means right. So we are going to go right 1. So every point is going to get moved right 1. My graph is still going to be a U-shaped graph. It's just going to be shifted right 1. Oops, sorry. All right, hopefully that's good enough there. So every point moved right 1. So the orange graph is the parent, and the green graph is f of x. I guess it would be a good idea to label your graphs. I always tell my students, I know which one is which, but anyway, I guess it would be a good idea to label that green one as that's the f of x. Okay, one more time we're going to use this parent function idea for this square root graph. So my parent would just be y equals square root x, the most basic form of a square root equation. Going to make a t-chart. If I plug in 0, I get 0 because the square root of 0 is 0. If I plug in 1, I get 1 because the square root of 1 is 1. If I plug in 2, I got to pull out my calculator. I don't really want to do that. So I'm going to plug in 4 because I know the square root of 4 is 2. So I was trying to come up with numbers that, I could, or square roots I could compute in my head. Now, if I tried to plug in a negative number, I'm just going to put a little frowny face here. The domain for square root functions is that x has to be greater than or equal to 0. Negative numbers underneath the square root would give us imaginary numbers, so not real numbers. So we don't want to plug in any negative numbers here. So I've got 0, 0, 1, 1, 4, 2. And because the domain is that x has to be greater than or equal to 0, I do not want to extend my graph beyond the point 0, 0. I tell my students, I think this looks like an eyebrow. So your square root functions are going to look like eyebrows. I don't know, looks like an eyebrow to me. So this isn't our final answer. This is the parent. We are going to want to shift this. So the +4 inside the grouping symbol means left. That's the weird one, counterintuitive. So left 4, and then out here it tells us up or down. It is intuitive. That means up 3. So we're going to go left 4, 1, 2, 3, 4, up 3, 1, 2, 3. So every point is going to move left 4, up 3. Left 4, up 3. All right, so this is f of x here. So the orange is my parent, the green is my answer. Okay, a piecewise function. Lots of graphing on this one. So for our piecewise function, we have a function that takes on or follows different rules for different parts of the domain. So I'm going to make myself 2 t-charts. The first t-chart is going to be for the rule x squared plus 3, and the second t-chart is for the rule 3x minus 1. Now for this x squared plus 3, that is the rule when x is less than or equal to 0. So values of x that I'm going to plug in are less than or equal to 0. So 0 would be good. That's less than or equal to 0. -1 would be good. That's smaller. -2. So I'm going to plug these into the rule. 0 squared is 0, plus 3 is 3. -1 squared is +1, plus 3 is 4. Just make sure when you square these negatives, you realize they're positive. So this would be 7. So let me go ahead and graph this. So I've got 0, 3, -1, 4, and -2, 7. And this is part of a parabola, so it's going to be kind of curvy. So this is the rule x squared plus 3 for x less than or equal to 0. Now once we get to 0 and x of 0, the rule changes to 3x minus 1. So I don't want to extend my graph at all. I stop there, and then the new rule applies. Now this is a little tricky. We want to plug in numbers greater than 0, but we still plug in 0 because we have to get super duper duper close to 0. Now when x is 0, the top rule applies, but when x is 0.0001, the bottom rule applies. So I can't just jump to 1. I still need to plug in 0, but I'm going to make a little note here. This circle will be open. I will not make it solid. So still plug in this number here. We just make it an open circle or point, not solid. So 0 gives me -1. I could plug in 1, 2. 1 would give me 2. 2 would give me 5. So I've got 0, -1, which is open. 1, 2, and 2, 5. So this is part of a line here. Okay. Oops. That last thing looks kind of funny. See if I can get that last thing up. Oh, that took, okay. Not bad. Okay, so here's what my piecewise function looks like. For x less than or equal to 0, we've got this rule applying. Then when x is greater than 0, the second rule applies. Open circle, okay, open circle there. We still plug 0 in. We just don't shade that in. X is greater than 0. It doesn't mean jump to 1. It means you start at 0. We just have an open circle there. Okay. I believe this is our last graph for a while. Okay, yeah, it's our last graph, then we get a little break from graphing. So we have a quadratic equation here, a quadratic function. We want to state the direction of opening, the vertex, the x-intercepts, the y-intercept, and the axis of symmetry, and then graph. Okay, so our direction of opening. This parabola opens down. I can tell that by just looking at the leading coefficient. The leading coefficient will tell you up or down. If the leading coefficient is negative, it opens down. Leading coefficient is positive, it opens up. So this one opens down. To find the x-coordinate of the vertex, which is also known as h, so maybe you learned it as h, we can use the formula negative b over 2a. Our a is negative 2, our b is negative 16, and our c is negative 24. I'm just taking those numbers from the equation. So to come up with the x-coordinate of our vertex, I'm going to negate b, which would then be a positive 16. And then in the denominator, I'm going to take 2 times a, which would be negative 4, and divide that out to get negative 4. So the x-coordinate of my vertex is negative 4. The y-coordinate of my vertex, which is also known as k, so maybe you learned it as k, we just take the x-coordinate and we plug it in to the equation. By order of operations, we do square first. So positive 16 times negative 2 would be negative 32 plus 64 minus 24. So it looks like we're going to get 8. So our vertex is the point negative 4, 8. So 1, 2, 3, 4, all the way up here to 8. So here's our vertex. I'll label it with a V. Now that vertex is going to be the high point of our parabola because it opens down. So when it opens down, our vertex is a maximum point, or the highest point. Okay, x-intercepts. So to find the x-intercepts, we let y be 0. So I need to solve the equation 0 equals negative 2x squared minus 16x minus 24. I could do that. That's not terrible, but I could also, what's going to make my life a little bit easier here, I notice that all terms are divisible by 2. In fact, I'm going to pick negative 2. So I'm going to divide both sides of my equation by negative 2. It's going to help. I can factor pretty quickly after I do this. So look for a common factor to make your factoring easier. So we have 0 equals x squared plus 8x plus 12. And then now I can see that to factor, since my leading coefficient is a 1, I just need to look for 2 numbers that add to 8 and multiply to 12. That would be 6 and 2. Those appear in my factors. So my factors are x plus 6 and x plus 2. And so my x-intercepts, therefore, when I set those factors to 0, I get negative 6 and negative 2. So my factor, or my x-intercepts are negative 6 and negative 2. Now, this is okay. You could also write them as ordered pairs. The ordered pairs would be negative 6, comma 0 and negative 2, comma 0. Okay. Y-intercept, that's next. The y-intercept is when we let x be 0. And if we're going to let x be 0 in this equation, any term that contains a variable is going to be gone. It's going to disappear. So our y-intercept is just going to be c, the very last number. So our y-intercept is negative 24. As an ordered pair, that would be 0, comma, negative 24. Now, if you look on the answer key, I have scaled the y-axis by something different. I think I went by 4s. In this one, I'm just going to choose not to graph the y-intercept because it's way off the graph and I've already plotted these points. So I'm just going to go ahead and just leave my y-intercept off. Won't be an issue on the test. Everything's going to fit. So, but for this one, I'll just go ahead and keep the both the x and y axes by 1, and we'll just leave off that. The axis of symmetry is the last thing. I might go ahead and graph and feel free, by the way, to include more points. If you'd like, you could plug in, like if you wanted to, you could plug in maybe -3 here and get a point. Sorry, this is supposed to be an upside down U. It's really kind of wavy. But anyway, you could find more points along that parabola. It's up to you. But the axis of symmetry, that's the line about which the parabola is symmetric, meaning that I could fold my paper along this line and the left and right side of the parabola would coincide. So the axis of symmetry is x equals -4. It is a line, so it's not just a number. Don't just say -4. Vertical lines start with x equals, and the -4, just notice it is the same thing as the x coordinate of the vertex, or the h. So our axis of symmetry has the equation x equals -b over 2a. So we can see that's the line about which the parabola is symmetric. Okay, next one, they ask us to put this in vertex form and then state the vertex. And to put this in vertex form, first thing I'm going to do is I'm going to add the 3 over. I just want to get it out of the way. I'm going to end up completing the square on the right-hand side. So let me go ahead and get that 3 out of the way. So I have f of x plus 3. The other thing I'm going to do in this step is I am going to factor out the 5, which is our a. So notice here, up here in